Hello students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving cubic inequalities on a number line, the sign diagram method. We have learned how to solve quadratic inequalities. Now we will be solving cubic inequalities. You can solve cubic inequalities using different methods. In this session, we will be learning about the sign diagram method or the number line method. Okay, so without any further delay, let us start with our today's session. Let us first of all look at the inequality that has been given to us. Solve x minus 1 times x plus 2 times 2x plus 1 greater than 0. Coming to the rules. Factorize the given cubic expression if not already factorized. Now this expression has been factorized, has been given in a factorized form. I have taken it in a factorized form because I did not want to waste any more time on factorization of a cubic polynomial. In case you don't know how to factorize a cubic polynomial or a cubic expression, I'll definitely be asking you to watch my videos on factorization of cubic expressions or cubic polynomials. Okay, so since it is already in a factorized form, we do not have to do anything more from using the rule number 1. We come to the rule number 2. Find the x-intercepts or the zeros or the critical values of the given expression. Okay, so the zeros means they are the x-intercepts, but there are people who do not like using this term zero because the inequality is not containing any equal to sign. But in case you graph this inequality, the expression will be passing through the x-axis at 3 different points, and those are the x-intercepts or the zeros. But since some people do not like calling those points as zeros when the inequality doesn't contain the equal to sign, I have written the critical values. They often use this term critical values, or you can use the x-intercepts. These are why the x-intercept term is widely used to refer to those points. Okay, the x coordinates will be giving us the x-intercepts. The y coordinates of those points will obviously be equal to 0 because they are points on the x-axis. Okay, so from the first factor we are seeing x-intercept is equal to 1. When x equal to 1, this part is equal to 0. So we get one of the x-intercepts as 1. From x plus 2, we get x equal to minus 2 as the second x-intercept. And from 2x plus 1, we get the x value as negative half or negative 0.5. Actually, I was not having much space, so I avoided writing a fraction, and instead of negative half, I have written negative 0.5. Okay, so we have found the x-intercepts of this given expression. Rule number 3 says draw the sign diagram to get the answer. So, and in case you're not familiar with this sign diagram, you can watch my solving of quadratic inequalities on a number line using the sign diagram method. Over there also you can see how do we use the sign diagram to get the values or get the solution set. Okay, so this is just basically a number line. These are all x values, and I have drawn these lines for the x-intercepts. See, x equals negative 2, x equals negative half, and x equals 1. So these three lines, these three x-intercepts are dividing this entire number line into 1, 2, 3, 4 subparts or 4 subregions. Okay, and we will be taking one x value from each of these 4 regions one by one, and we will be substituting in this expression. To find out whether the expression value after substitution becomes equal to a positive number or a negative number. Because we need a positive number, this expression value should be greater than 0. So it should be a positive number. So we will be taking values from each of these 4 regions one by one, substituting them in place of x in the given expression, and we will be finding the value of the expression every time to check whether we are getting a positive number or a negative number. The number is not at all important. The sign is important to us. Okay. So we start with the leftmost region. I have taken x equals negative 4. You can take any value of x lying to the left side of negative 2. Okay. You can take x equals negative 3. You can take x equals negative 10. Any value. But it should be lying towards the left side of negative 2. And in place of x, I am substituting minus 4. So minus 4 minus 1. Again minus 4 plus 2. And 2 times minus 4 plus 1. So what are we getting? Minus 4 minus 1 is minus 5. This one is minus 4 plus 2 is minus 2. This one is 2 times minus 4 is minus 8 plus 1 is minus 7. So minus 5 times minus 2 is plus 10 times minus 7 is minus 70. It is a negative number. So we write this negative sign. I have said the sign is important. Whether we are getting minus 70 or minus 35 doesn't matter. Because if instead of x equals negative 4, you take x equals negative 3, obviously the number will be different. But it will be a negative number. That is which is of interest to us, whether the product is a negative number or a positive number. So it will always be a negative number, whatever value you take for x from this region. Okay. So we are getting negative products for values of x from this region. And we are not interested in negative products. So we move on to the next region. That is from negative 2 to negative 2 to negative 0.5 or negative half. And I have taken the x value to be equal to x equals negative 1. You can take any other value. You can take negative 1.5. I have taken x equals negative 1. And then again I'll be substituting this negative 1 value in this expression. It is negative 1, negative 1, negative 1, positive 2. 2 times negative 1 plus 1. So minus 1 is minus 2. Minus 1 plus 2 is plus 1. And 2 times negative 1 is negative 2 plus 1 is negative 1. So it is negative 2 times 1 is negative 2 times negative 1 is a positive 2. So the sign of the product is a positive sign. We will be getting all positive products for any value of x from this region. Okay. So this region is of interest to us, but we have to try the other regions also to find out whether they have positive products as well. Okay. They give positive products as well. So we come to this region from negative half to positive 1. And it is, I have taken x equals 0 from this region. 0 minus 1 and 0 plus 2 and 2 times 0 plus 1. So this is minus 1 times plus 2 is minus 2 times positive 1. So it is negative 2. A negative product. Finally, we come to the rightmost region and I have taken x equals 2. 2 minus 1, 2 plus 2 and 2 times 2 plus 1. 2 minus 1 is 1, 2 times 2, 2 plus 2 is 4 and 2 times 2, 4 plus 1 is 5. 4 times 5 is 20. So it is a positive number. So these two regions between negative 2 to negative half and above 1, these two regions are giving us positive products. So these two regions will be included in our solution set. Okay, this is how we use the number line method or the sign diagram method, where we divide the whole number line into different subregions. And the division is done by getting the x-intercepts. They divide the whole number line into different subparts. For a quadratic inequality, we had at most 2 x-intercepts. So the number of subdivisions that we had for a quadratic inequality was equal to 3. In this cubic inequality, the maximum number of x-intercepts that we can have is 3. So the whole number line is getting divided into 4 subregions. Okay. And now that we have got the two regions that will be giving us positive products, it is the time for us to write the final answer. So x should be greater than -2. We cannot include the x-intercepts because equality sign is not included within the given inequality. So it should be x is greater than -2 but is less than -half or -0.5, or it should be or, because x is a number. It cannot simultaneously be equal to -1, suppose, and equal to 2. So it should be either -1 or 2. Therefore, the two regions should be connected by this word or and not and. Okay. So x is greater than 1. So either you have x value in this region or you have the x value from this region. This is the writing of the answer in inequality form. You can write the same answer in interval notation form. This is the interval notation form of giving the same answer. X belongs to this interval -2, -0.5. I could have used the parenthesis as well. These two means these are open square brackets. That means these two values are not included within the solution set. And in place of or, we have this union sign and 1, infinity. So you can go to up to any higher value of x as you want. You can move towards the infinity. Obviously, you can never reach infinity. Infinity is not any number, but the number should be greater than 1. We are having this open square brackets. Okay, so this is our final answer. I hope you have understood this method. In case you have any query, any doubt, please feel free to write to me in the comment area. I'll be trying to answer those questions of yours. Okay, so students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.